Hi, welcome back. In this video, we are going to start the review at number 4. Given the rhombus below, write down the steps you would use to solve for x. Okay. The first thing I would do is I'd say, okay, it's a rhombus, which means the diagonals are bisected. So, 32 on both angles in that corner. 32 and 32. Okay? And the way I'm doing this is not necessarily the way it has to be done. This is just the method I'm going to use. You do probably need to start with that, with the diagonals. Not diagonals are bisected. Diagonals bisect the angles. Diagonals bisect the angles. Diagonals are bisected, but that's not what I used there. Diagonals bisect the angles. Right? So these are both going to be 32. Okay? So then, the next thing I would think about is the diagonals intersect in a rhombus at 90 degrees. And so all of these angles here are all 90 degrees. That's going to help me. I could use the idea that triangles are 180, so I could figure out what that angle there is. I could also talk about how my opposite angles are the same, right? Opposite, because it's a parallelogram, opposite angles are congruent. So that means if these two are both 32, guess what? These two up here are both 32. Okay, oh look, now we're real close to finding that x. All we have to know now is that the angles in a triangle add up to 180. Angles in a triangle add to 180. Because I've got 90 in this, if I look at this triangle here, right, I've got 90 and 32. Out of the 180. So this angle here must be 58 degrees. Okay? All right, let's look at number 5. June built a fence to surround her property. On a coordinate plane, the 4 corners of the fence are located at these coordinates. What is the most specific classification of her property? All right, so let us graph these. -4, 1, -4, 1, 1, 3, 1, 1, 2, 3, 3, 1, or sorry, 3, -1, and 1, -1. All right, so I'm gonna go with this is probably not a parallelogram because I have a little horizontal piece here and there's no other horizontal pieces in my figure, so there's nothing to be parallel to this one. So it's definitely not a parallelogram, okay? I do know it's for sure a polygon because it's closed and it's made with segments. It's definitely a quadrilateral because it's got 4 sides. Okay, but since there's not going to be anything parallel to this piece right here, it's not going to be a parallelogram, which means it can't be a rectangle, it can't be a rhombus, and it can't be a square, right? So I'm stuck so far here. Then the next things I looked at were kite and trapezoid. For it to be a trapezoid, I'm going to have 1 pair of parallel sides. Well, I already know these two are not going to be parallel. So then if I look at these two, are these going to be parallel? I'm pretty sure they're going to intersect down here somewhere. But do they have the same slope? Down 1, 2, 3, 4 over 2. Down 1, 2, 3 over 1, 2, 3, 4, 5. So 3/5 and 4 over 2 is really 2 over 1. So they don't have the same slopes. It's not a trapezoid. Okay? Is it a kite? Are they going to have are consecutive sides going to be the same? So I know this is 2 units. Is this here going to be 2 units? I'm pretty sure that's going to be longer than 2 units. Because if I make a little right triangle here, I've got 2 units here, and this is the hypotenuse. So this has to be longer than 2, so these 2 can't be the same. Can these 2 be the same? I don't think so, right? If I look at these 2, and I want to know how long this piece here is, if I make that a hypotenuse, again, it's got a 2 here, so that's definitely longer than 2. It's not a kite, it's not a trapezoid, it's not a rectangle, rhombus, parallelogram, so I can only call this a polygon, and I can only call this a quadrilateral. So when it asks me for the most specific, if I call it a polygon, that's not correct, because that's not the most specific. That's the most general I could possibly be. So my answer here is quadrilateral. Okay, let's look at number 6. Number 6, parallelogram WXYZ has vertices -3, 7, 4, 7, and 2, 2. Find the coordinates of Z and the area of the parallelogram. So I have W at -3, 7. I have X at 4, 7. I have Y at 2, 2. And I'm trying to figure out where to put Z. Remember, order is important. I have to connect W to X. Those have to connect. And then I have to connect X to Y. Those have to connect. And then I have to connect Y to Z. So that means I can tell my parallelogram is going to have to come somewhere over here, right? I can do it either using these 2 have to be the same length, or I can say these 2 have to have the same slope. So I could come down 1, 2, 3, 4, 5 over 2, 1, 2, 3, 4, 5 over 2. Or I could have said this is 1, 2, 3, 4, 5, 6, 7. So this is 1, 2, 3, 4, 5, 6, 7. Either way would work just fine. To find that Z is at -5, 2. Remember, order is important. I could have put Z over here and made a parallelogram here, but then I'd have had WXZY, right? Order is important. It also says to find the area of this parallelogram, so that's going to be base times height. I already counted the base, but in case you forgot, it's 1, 2, 3, 4, 5, 6, 7. And my height is 1, 2, 3, 4, 5. 7 times 5, my area is 35. I don't know what the units are here. It's definitely smaller than a centimeter. But I don't put the square on the 35. Whatever my units are, that's what gets the square. So here's the coordinates for Z, and here is the area. Okay? All right, in the next video, we are going to look at problems. If I can turn the page. We're going to look at problems 7 through 11. All right, so come on back for 7 through 11. Thanks for watching.